Hello, good morning, good afternoon, good evening. This is the first lesson on ARCH260 sustainable buildings or sustainable building design. What are we going to speak about in this course? We're going to speak about buildings and we're going to speak about sustainability. I like this picture because it summarizes everything we are going to see or we're going to learn in this course over the next few months. Here we have a modern, nice and modern building, and we can see that there are a lot of natural resources we have to use. This is sustainable design. We have to integrate buildings, we have to integrate a nice building, a nice design with natural resources. And if we are able to achieve that, then we can say that we are sustainable architects. It's not easy, and this is the first step. This is your first step to become sustainable architects. But if we analyze this picture, what can we see? We see that basically we have 4 elements that we have to use. We have sun. Sun is very important. It's the main source of energy. We have an earth. The energy that we receive from the sun, it's outstanding, it's incredible. We have water for free, it rains, and we have free water, and we have to use it. And we have fresh air. So those are the 3 elements that we have to use: sun, water, and fresh air. And 3 elements are for free, we don't have to buy them. And finally, we can make the most of green, we can make the most of trees and green stuff. So putting everything together, we have a building, we use natural resources to provide the building with the needs, with the energy, with water, with fresh air, and then we can surround the building with landscape to make it more beautiful, more appealing, and again, to make the most of these trees, because trees are outstanding elements that can reduce the temperature of the air, can provide us with shade in summer. So we have to use this kind of trees. That's another picture showing exactly the same. So we have a building here, but here we have something else. We have to make the most of these natural resources, but we need we need to understand how to place those elements. We have tanks here, we have storage tanks for water. We can have storage tank for cold water, another one for hot water, because we need water at different temperatures in buildings. Then we need pipes, because we need to lead the water from the tank to the place where we are in the building. We need openings to provide the building with fresh air. We need openings, we need glass. Glass is an amazing element. It's a transparent stuff, and it allows the sun energy and the sunlight enter the building. And finally, we need trees here. So if we have a large area of glass, we can use trees to provide this glass area with shade in summer. In winter, most likely, the trees will lose their leaves and it will allow the sun to enter it. So we can use the sun energy to heat up buildings in winter, and we can use trees to provide buildings with shade in summer. So we are thinking about natural resources here. So this is the goal. So we will learn how to design these kind of buildings. But first, we need to analyze things, and we need to understand where we are. We are in New Hampshire, in the United States, but we are in the world, we are on the planet Earth, and we need to look at the global perspective. So this is what we are going to explain right now. So this is not a building. This is the amount of energy, or the total energy that we are using in the world. it's not a country, it's the whole world. So we have 4 sectors. We have transportation, we have industrial sector, we have residential and commercial. Everything related with residential and commercial is about buildings. Transportation is about planes, trains, cars, boats, whatever. Industrial is the energy we need to manufacture things. But residential and commercial, it's about buildings. It's the houses where we live. It's the shops or the malls we go to buy things. But almost half the energy that we need in the world is for using that energy on buildings. So we, as architects, we have a lot of responsibility because almost half the energy that people are using in the world is for running buildings. If we look at this, if we look at the buildings, what do we need? We need lighting, artificial lighting. We need space heating. We need space cooling. We need to heat up water because we need hot water. We have ventilation, and we have equipment and devices, computers, TVs, everything that we can plug, and everything that runs on electricity. Okay, so if we look at this, we can see that lighting is about 40% of the energy needs of a building, and space heating and cooling, it's around 40%. So we have 20% for water heating, ventilation, and appliances. So what do we have? If we're designing a building, what do we have to do? We have to provide the building with natural light. We have to reduce as much as possible this green slice of the pie. And we have to reduce the space heating and the space cooling. And what can we do? What can we use? What natural resource can we use to do this? Sun. If we have natural light, this is about the sun. If we can heat up spaces with the sun energy, and we can heat up water with the sun. For space cooling, we would need electricity, and we also can use PV panels, photovoltaic panels, to generate electricity out of the sun. Okay, so sun is everywhere here. So if we make the most of the sun that we receive in our building, we can reduce the amount of energy that we are using a lot. And by reducing the amount of energy that we are using in our buildings, we can help others reduce the amount of energy that we are using in the whole world. People, the transportation industry, they will be making something, and the industrial, they will be thinking how to reduce the energy that we are using in these 2 sectors. But architects, we have to think of how to reduce energy on residential buildings and commercial buildings. Well, this is interesting. This is the world energy consumption. This is the world energy consumption, the energy that we have consumed since 1965. Why 1965? Well, because as you can see, the energy that we consumed the first half of the 20th century, it wasn't that much. So there has been a tremendous increase on the energy that we have consumed, especially over the last decade, since 2005 until 2015. So we have increased a lot the energy consumption the global energy consumption. Why? There are a lot of factors here, but there's a factor that happened here, 2004, 2005, and as you can see here, the slope of this curve or this line changes dramatically. Well, I think I have an explanation for that, and the explanation is that China started producing things. China was a developing country, well, not a developing country, it was a country devoted to agriculture and farming, but it became an industrial powerhouse, and that affected the energy consumption. Okay, so all the countries were steadily increasing the energy consumption, but suddenly something happened here, and I think it was because China became an industrial powerhouse. Something happened here in this decade But here we can see that we have this horizontal trend again. Where are we now? Well, we don't know where we are now because those statistics, we cannot have the 2020 statistics. I don't know what is going on in the world today with this COVID and all these crazy things that are going on. But we can see that from 2013 to 2017, there is not the slope of this line is flat again. We have had a lot of issues over the last decade. We have had recessions, we have had pandemics, we have had a lot of things. Okay, so but nowadays, I think we are looking at decrease, not a decrease, but at least it's not. We are not increasing the energy consumption. Is it because we have renewable energy? Maybe it is because we have renewable energy, but well, we need to know where we are. And the second thing that I want to show you in this graphic is the energy sources. So those are the typical energy sources that we consume, or we need to produce electricity or to fill the tank of our cars. We have oil, we have coal, we have natural gas, we have nuclear plants, hydro plants, and renewable energies. Well, nuclear and hydro can be considered as renewable. We will talk about this over the next few weeks. But basically, if you can see this, coal is the most important source of energy in our world. This is bad news because by burning coal, we are generating a lot of greenhouse gases. So our commitment as human beings, we have to reduce the energy consumption, and especially we have to reduce the amount of coal we are burning. Burning oil is not good for the environment, but it's not as bad as coal. And natural gas, it's much better. So that's why in the United States or over Europe, we are replacing old boilers that run on coal or oil with boilers that burn natural gas because it's much more environmental friendly. Anyway, we have to be committed to renewable energies, and we have to try to integrate renewable energies in our building. Well, here we see what has happened until 2020, and we can see projections. Okay, so where will we be at in 2040? We don't know, but if things go as planned, we will have an increase on natural gas consumption. We won't have an increase on coal consumption. It doesn't mean that coal is going to disappear. We don't have to be naive. People or different countries will keep on burning coal, and and there's growth. There's steady growth in the consumption of renewables on renewable energies. We will keep on burning oil, and I think the nuclear plants won't grow. So nuclear plants are huge investments, and the operation cycle of nuclear plants is about 40 or 50 years. So most of the nuclear plants that are running right now will continue to run by 2040. But the trend nowadays is not to build more nuclear plants. When it comes to countries and the energy consumed by different countries, okay, so we see China, United States, the rest of the world. Okay, so basically China, India, the United States consume half the energy of the world. again, if we are living in China, we are living in the United States, we have a commitment, so we can save a lot of energy. So by designing efficient buildings, by designing efficient transportation methods, this is not our responsibility. But in these two countries, if we reduce by half the energy consumption in these two countries, we will save the world, basically. Okay? So it's important to get to know where we are, because if we are, I don't know, Hong Kong, what if we reduce by half the energy consumption in Hong Kong? It's not a big deal, looking at the global picture. But if we reduce the China and the United States energy consumption, we can achieve great things. What is this? Okay, this is the United States. So we are narrowing down the scope, and now we are looking at the United States in 2010 and 2013. So there's a trend in the world. We are increasing the renewable energy production. So in 2010 it was 8%. In 2013 it was 9%. It's a very slow growth, but this is a trend. So in all countries we are increasing the renewable energy production. And in 2016 now it's 10%. So we had 8%, then 9%, 5 years after we have 10%. So we are slowly but surely increasing the renewable energy production. What about other countries? What's going on in other countries? Well, here in 2018 we have 11. Okay, so we have 8, 9, 10, 11. In other countries, like China, for example, they are developing the industry. So they started becoming an industrial country 10 years ago or 15 years ago, and they're still making the most of their natural resources. And what is the main resources they have? Coal. So they're burning 89% of the energy that they are producing is by burning coal. They have a very narrow market of renewable energies. But I'm sure that in 10 years that will be close to 10%. What about Germany? So if we think of a country that is committed to not to the global warming, to fight against global warming, is Germany. So they have a lot of things. They have efficient cars. They recycle. But if we look at their renewable energy production, it's 12.6. So it's very close to remember that in the United States it was the 11%. So the United States is not far from the. I mean, I'm showing you the German production, because it's when we think of a sustainable country, we think of Germany. Okay, so and the United States it's not far. We always can improve the performance, and we always can improve the renewable energy production. But if we look at the rest of the world, the United States, it's in the average. It's above the average, I would say. Well, why are we explaining this? Because if we don't take care of this, if we don't use renewable resources, this is what will happen. We will keep on burning things. We will keep on burning fuels, coal, gas, oil, and our industries, our buildings will emit a lot of, or will release a lot of greenhouse gases. And this is terrible, not only because it's ugly, but it's bad for health, and there will be a lot of issues if we don't cut down on these greenhouse emissions. Again, if we look at different sectors, we have industry, we have transportation, and we have agriculture, and then we have commercial, residential, and then electricity. Okay, so if we look at the greenhouse emissions, buildings are not responsible for half of the greenhouse emissions that we have in the world. Well, looking at this, because electricity, there are a lot of, we use a lot of electricity in our buildings. So part of this 28% is about buildings again. Okay, so we can, with a good design, we can control greenhouse emissions in buildings. And here we have greenhouse emission by sectors. Yeah, we have industry, we have transport, we have residential buildings, so this is pretty much the same. And this is the greenhouse emissions by countries. So again, we have China and the United States. Okay, so again, these two countries, they consume almost half the energy of the world, and these two countries are responsible for almost half of the greenhouse gas emissions. Okay, so we have to reduce this percentage. And this is very interesting too, because these are the gas emissions or the CO2 emissions by fuel. Okay, so if we burn anything, we emit CO2. This is chemistry, basic chemistry. So what can we burn? We can burn oil, we can burn gasoline, diesel, biodiesel, coal, wood. Okay, so that's interesting. If we burn coal, that's terrible, we know that. But if we burn wood, it's not good enough. Well, it's even worse than coal. Okay, sometimes we tend to think, okay, wood is a natural element, we can burn it, and yeah, it's natural, and we can burn it, yes. It's renewable, yeah, there are a lot of trees, and we can plant more trees if we... But when it comes to CO2 emissions, burning wood is not a good option. So keep that in mind. The best option is methane. It's a natural gas. Okay, so the gas that we use in our houses is this. So it's quite good, because when it comes to CO2 emissions, methane, it's a good option. The problem is that it's not renewable. So eventually we will run out of methane in the world. Okay, so it's not an option for the future in 100 or 200 years. But it's interesting, because we tend to think that wood is the best material. Okay, I have a wood stove or whatever. Okay, by burning wood, you emit a lot of CO2. And think about it. Energy in buildings. We are used to looking at our devices, our refrigerators, washing machines, and we have labels like this. We have from A to G, or we have A plus, or AA triple plus, whatever. But in buildings, we are having the same. So anytime you are buying a new building, or you are, as an architect, you design a new building, you need to you need a category. So you can have an A building. That means that it's a building that doesn't require a lot of energy to run and doesn't emit CO2 or any other greenhouse gases. So it's a good building. If you are designing a G building, well, probably you will get paid, but you are not contributing to make this world a better place. And we need to understand where we are. We are in the United States. We are in New Hampshire, New Hampshire, and because designing buildings, it's we cannot design a building without looking at the location. A building in Florida shouldn't be the same as a building in Canada or in the Rocky Mountains or whatever. And here we have, by looking at this map, we can understand that we have in the United States a cold area. So New Hampshire is in this cold area with these average temperatures. We have a hot area here in California, the Gulf of Mexico. And then we have a central area which is cold in winter, hot in summer. Okay, but looking at this, if we are designing buildings, residential buildings or commercial buildings in New Hampshire, we need to understand that it's a heating-dominated weather. So the most important thing in this area of the world would be provide the building with a good heating system. In Florida, the heating system is not relevant. They need they are worried about the hot weather. Okay? So depending on where we are working, our design has to be different. And there is not a recipe for... Now, we have to look at what we are doing. We have to look at vernacular architecture or traditional architecture when people didn't have resources, didn't have energy. What did they do to achieve comfort within buildings? So we have to look at that. Okay, so that's it. This is the first lesson. What tools are we going to use in this course? Well, we're going to use basic tools. We're going to use Word, the Office Pack, Word, Excel, PowerPoint, and then I will try to introduce, because we have to design a building. If you are familiar with SketchUp, you can use SketchUp, or if you are familiar with Revit, we can use Revit. I will teach you how to use Revit, how to design something very simple in Revit. So if you have not taken a CAD 2 or Revit, don't worry, because we are going to start from scratch. But I think by using Revit, we will have a lot of possibilities when it comes to analyzing the thermal performance of buildings. That's all. See you.